Hello and welcome to the first part of the lecture for Chapter 1 for Psych 319. I'm just going to briefly go over some of the course objectives. Cognitive science is really about learning about the basic cognitive processes that make up of thinking. We tend to think of things as thinking as being one process, but it's actually made up of a bunch of things. So what are the basic cognitive processes? They include, but are not limited to, perception, language, attention, navigating through the environment, reasoning, decision making, pretty much everything. The one thing that's true about cognitive science is your brain is the filter for all the information that comes into you, and it is also the governor of all the actions that you do and the way you interact with the world. So cognitive science really actually relates to pretty much everything about you. So how does the brain represent knowledge? That's a question we'll be asking and answering in this course. How is knowledge acquired? How is it stored and retrieved? How does it help us interact with the world? These are all things that should be very pertinent to you. But the one thing that makes cognitive psychology unique is that it's all about addressing human information processing. So we're not really that concerned with physiology. Cognitive psychologists assume the brain is like a black box. And we know that there's squishy stuff that goes inside your skull, but we're not as concerned about that as we are with how the information is processed. And then you can use that knowledge to guide physiological studies, because the ultimate goal is to sort of relate physiology to behavior in psychology. And this is the first step to that process. We'll also, in this course, learn how to conduct good experiments. This is a laboratory class, so there's going to be a focus on experimentation. We're going to learn how to ask the right questions in experiments, how to measure and collect data correctly, and how to analyze and interpret that data. First part of the lecture, your brain is amazing but not perfect. I'd like to show you a simple visual illusion and decide for yourself which three of these blue spots on the screen is the brightest. Most of you will probably say that the spot on the lower right is the brightest spot. But if you actually take a piece of paper and cut out three holes that correspond to the three blue spots, you'll see that they're actually the exact same brightness and color. What varies is the context. And so the reason, there are many visual illusions you can find on the internet, and the reason I show you this is to show you that the brain is responsible for processing a lot of information, and we don't always get that right. We oftentimes think that we're getting it right, but we don't. Here, the brightness of each blue spot depends heavily on the context in which it's situated. So by biasing the context, we can bias the perception of a physical stimulus. So another example, that our bias in judgment not only goes for perception, but also the perception and judgment of other people. So I'm not going to show you this now, but I want you to play this little game. Go to the URL indicated up here at the top of the screen and play this game and see if you can get 100% correct on the game. The idea is to determine which of the people are programming language inventors or serial killers, and I'll bet you can't get them all right. And the reason is we use a lot of heuristics or cognitive shortcuts to try and guess what people are like, what people, there would be behaviors like, whether they're nice, whether they're mean, whether they're smart, whether they're slow. And we use physical appearance to judge people a lot. That's not always an accurate thing to do, as I'm sure you know, but this game only highlights that fact. So the next slide here, I want to play another game with you. Who do you think is happier 1 year after this major event? So the fellow on the left has had lost both his legs in a car accident, and the woman on the right won the lottery. And 1 year later, who would you expect is going to be happier? Well, many people probably think, losing your legs is a very, very difficult thing, and of course that would be true. Nobody wants to lose their legs, but and you might think actually that the data comes back. If you surveyed a group of people who had had a major tragedy and a major success in their life, 1 year later, who do you think went better? Lottery winners are paraplegics. Most people would say lottery winners, and here's some data. happiness 1 year after the fact, number of people after the incidents, and we call this effective forecasting. How good do you how happy do you think you're going to be after a major event? But the truth is that actual data looks like this. What I showed you is fake data. It turns out that lottery winners and paraplegics are just as happy 1 year after an event. So that's kind of shocking news. And you might think that this tells us a lot about our ability to uh, predict the future, and it does. What we've learned from these experiments are that people are not very good at determining what will make them happy. And it also shows us that we tend to make the best of a bad situation. If you are paraplegic, you're not going to get your legs back, so you do the best with the rest of your life that you can. And sometimes it's a wake-up call for people to live a better life, and they end up being happier. These are published results in a book called Stumbling Upon Happiness, and you can also find a more elaborate talk on this subject by Dan Gilbert from Harvard at TED.com. That's TED.com. Just do a search for his name. All right, and hopefully I'll have enough time for this last bit here. So there are also shocking news from split brain studies. They tell us a lot about how we think and how we reason. So when a person has epilepsy really, really, really bad, no, sorry, let me first give you a brief tour of the anatomy. The brain has two cerebral hemispheres that are connected by this middle structure, the corpus callosum. And that allows the two hemispheres to share information. People who have severe epileptic seizures can, the seizure can start from one part of the brain and spread to the other. So if it gets really, really bad, we're talking 100, 200 seizures per day, a surgeon will cut the corpus callosum so that the seizure activity doesn't spread to the other hemisphere, and in some cases this saves people's lives. But what can happen is you get this weird phenomenon where information doesn't flow back and forth between the two hemispheres. So imagine, a little more background information. The right hemisphere, so back here is visual cortex, and right visual cortex is responsible for processing information on the left hand of visual space. Okay, and the opposite is true as well. So if I show you a picture of a flower over here, your right hemisphere will process that visual information, and normally it'll send that to the language centers of the brain, which are in the left hemisphere, and you'll be able to say, I see a flower. That's how it works normally. What's interesting is language is only processed in the left hemisphere. Okay, so you don't have language centers in both sides of your brain. Now, if a patient who has had their corpus callosum severed tries to do this task, and you show them a flower in their left visual field, they will be able to see it because their right hemisphere is still functioning. But that information does not get passed to the language centers, and therefore they don't acknowledge it. So even though their visual system is working, they don't see it. And as a result, they don't have the perception of seeing it. You can ask them, is there anything in their left visual hemisphere? And they'll say no. Now, the weird thing about smell is, smell works the opposite way. The left nostril goes to the left side of the brain, and the right nostril goes to the right side of the brain. And if you plug up their right nostril and you just allow them to smell the flower, they'll be able to say, oh yes, it's a flower. So they can identify what the object is, and these people are not blind. It just seems that the access to the language areas appears to be critical, or a critical element for awareness. And the reason I bring this up is there's a separation between perception, the ability to see, and the awareness of being able to see. And so another sort of way your brain plays tricks on you. So perception is independent of sensation. A sensation is the initial encoding of a sensory stimulus. Perception is a mental construction based on sensations. It's your interpretation of the world. And this brings about the question of metacognition. So metacognition is being aware of having these thought processes, being aware of the fact that you have perception, and that perception is an interpretation of the world. So we're typically consciously aware of something if that thing is allowed to reach the brain centers responsible for verbal communication. And that also brings up my theory on American Idol. So perhaps the part of the brain that is responsible for singing is located very, very far away from the part of the brain that is aware that you know you can sing. which might explain why some of these people think they're brilliant, but they're actually quite terrible performers. A separation between performance and conscious awareness of that performance.